Hello, everybody. This is going to be a little less structured of a stream than I've done over the last few sessions, mainly because I haven't really planned out in any meaningful capacity what it is I'm going to do today. And hi, Puff and Fresh. So I guess this works out a little bit better as a time slot for you. The main thing I was thinking about doing was diving in a little bit more on abstract machines. Maybe going through... There's a paper by Sestoff that goes through and derives from an old paper by Launchberry, an old approach by Launchberry, a virtual machine for a lazy language. And I think that might be a thing we could do together. Like I said, I haven't done this before, so I don't actually know how well it would work out. The other thing that we might want to do is see if we could get the abstract machine that we built last time to be a little bit closer to something we might want to run directly on hardware or in the... I don't know what was going on. I can try and fiddle with my colors now that I'm on the stream. Properties, am I fading into my background or am I just pale? Let's see. It's a different time of day than I usually stream, and so more light's coming in through the windows. I should probably get some blackout curtains or something. Filter, color correction. Let me add some saturation there. I can look very, very bright. Opposite of ghostly, at least. But now I look very yellow. At least closer to true color. And yeah, my mouth is stuck in the background because it seems to want a chroma key off of it. I'm not quite sure what's going on in there. It shouldn't be green. It's not. I promise. Color filters. If I try and keep that from going off, I probably start getting the background to show, to shimmer through. That's about as close as I can get. I don't see any. I don't see my mouth going anymore. All right, that's at least something. That'll be a great thing for the archives right there. So let's see here. Maybe I'll slide my window over a little bit so that Alex Mason doesn't have to fight. Green tone to my skin. I'm not quite sure what's going on there. Any lambda in the cheek is yeah, not intentional. That should probably be about the right size. And I completely forgot to adjust the stream speed. I apologize to everybody who had asked me to. Maybe doing the S for the CESK machine would be a good idea too. That's a good idea. Going to write Age of Empires and for Art of the Troll. Got it. Let's see here. What do we want to do? So I had a little CEK folder in there. I had a CEK simple and a little type machine. I'll drag that off screen so I can see something. So, I mean, I guess one of the things that we might want to do is we have this really, typed CEK machine. I might like to, actually just have an integer for bound variables and see if we can fix that up. That would let us have environments that are just like sequences of variables, I think. So last time we built a CEK machine, we didn't get to the CESK machine. We just had expressions that we made into a monad, and then we made the whole thing strongly typed by the end of the session. but it might be good to, instead of doing this where we have one var type where we pick up maybes, where the nothings are the bound variables and the a's are the unbound variables, are the free variables. What we could do is we could switch to a less explicit, much easier to screw up, and we'll probably screw it up in the process, version of this with like a separate bound constructor, which keeps track of like the number of lambdas out that we're looking. And then these could be some lookup in an environment. So let's do that. Let's see how badly I'll screw that up. So for right now, the A is just going to be the thing that we're going to look up in like the signature that we're working with. So like the signature for here, I guess will be like the set of top level functions that are in scope. Those will be the things that we're going to look up with vars now. And then expressions, the bound constructor will be referencing n lambdas out. And it's probably safer not to have the applicative and monad lying around here, because the substitution and instantiation for that's wrong. And in this setting, now we're going to have to be explicit about this being an exp of A. And to kind of keep track of things, even though I'm not going to like make a new type out of it, I'm going to keep track of things that are like this used to be an expression of maybe, so I'm going to just call these things abstractions, and maybe that'll work. Hopefully I've got the code up on the screen. I do. All right. So what we're going to have to do when we want to abstract over a variable, an abstraction over a variable is going to have to run down through and check for A equals B, and instead of just giving back nothing at that appropriate level, it's going to have to do something awful where it has to keep track of the number of bound, or the number of lambdas between where we're doing the abstraction and where we are. So let's see here. Abstract it. We're going to just keep count or something like that. Go 0, go k, var b. If A is b, this is just bound k, otherwise it's var b. I guess we can just reuse the type because it's the same type. What else we got? We're gonna have to recurse through all of this crap manually. If we're trying to abstract over a bound, we see an existing bound variable, we're just gonna give it back app lr, app go kl, go kr. I have a lam for another variable. We have some lam body. What are we doing in here? We're going to go through and go k plus 1 body, and then just bolt that onto a lambda. So if we've seen an intermediate lambda and we're trying to abstract over a variable, we're going to keep rummaging around inside of there, but anytime we see that variable, we're going to replace it with a bound variable that's had its counter bumped up. How would I represent let bound variables with var or bound? So for me, the let bound variables would be bound variables, and then I would bind n variables at a time. So I would make something like, in this setting, here's a list of expressions of A or something like that, and an expression of A. And then the bound variables in here, starting from 0, 1, 2, 3, 4, 5, whatever would be indexes into this list, and then we go deeper into that. Probably backwards, but yeah. And so all of these expressions would be bound in all of these expressions if you built a let rec. I'm deliberately avoiding building a lambda calculus with let because because it's a slight mess, but it's not that bad. Now that we have abstraction in theory, I guess we don't need this thing anymore. What else do we need? So we've built lam. Closed is still fine. All of this stuff. Environments, I'm kind of sick of these environments, so let's just do them as sequences of values. And values are now going to be hold on to a type parameter, I think. And we don't need any magic there. And I think in this world we're going to be able to get away with values always holding on to a thing. So this is just going to be a closure of a abstraction of A and an environment of A. And I think we're going to be able to say, hey, cont always takes an A. So we can just, for top or arg expa env A cont A, or I think this is going to work. I'm making it up as I go. This is an abstraction because it's an expression of maybe. Env of A, cont of A. And now we can just driving cont. That would be nice. Driving show, I mean. Driving show here. We already have a show instance for that. This thing drives show. I believe all of that. That seems plausible. That's much simpler. I like that. State A is state holding onto an expression of A, an environment of a continuation of A's. We can just driving show all the way down. That's all plausible. We're going to take an expression of A's and give you back a state of A's. And now we don't need an environment that it's absurd. We're just going to give back empty, the empty sequence. So that works good. I'm pretty happy with that. So now the A is going to reference some kind of signature. So we might have sig of A is going to be given an A, I'll give you a value of A. This will be top level lookups, I think. So we have expression void. This doesn't reference any top level terms. This could be for any signature. I don't care. And step, I think, should take the signature, the thing to look up the top level environment, to step from state to state. And this should just be an environment lookup for that variable in the signature. And then a bound variable will instead look up in the environment, which I believe is sequence index. So we'll import data.sequence as seq. And then we'll use the index function out of it. Yep, that looks right. Sequence index int A. Okay, so if we see a free variable, we look it up in the signature, which is our top-level definitions. The top-level definitions don't change anywhere, so we just use them everywhere. Bound variables we go look up in the sequence for the current environment. And applications, this looks plausible-ish to me. We go into the argument side, or we go into evaluate the function body until it runs, and then we come back out and we do the other side. Lambdas, in the case where this is a top, we've hit the final continuation, we're just going to give back the current state, we're stuck. Otherwise, for lambda, we're in an arg continuation, we're going to move into a place where we've got the function continuation to glue the things together. We've got the function continuation, we're going to extend. I think we're going to extend the environment on the left, which would be that they become zeros and everything else gets increased by 1. That looks plausible to me. So extend should just be done. Final takes a state A to state A, and this needs to take a sig. And what is this, our old big step semantics, kind of hackish kind of thing? Expression of A to env of A to continuation of A to state of A, which will also take a sig of A. We'll do the same kind of lookups, most likely. I'm making this up as I go, so you see something, say something. Yeah, sig environment, sequence environment. Everything there looks plausible, and extension is now just consts in sequence. That look plausible to folks? Conflicting definitions for K. Oh yeah, bound B. I don't care what you bound. '96 requires a env. What is env? Env of A is a sequence of values. Oh, these didn't. I didn't pass sig through. There's total code duplication between big and step. The whole goal of big is to explore what this thing looks like if it does recursion. My hope is that by using big, we'll be able to eventually get a kind of a Fudemura projection trick that I want to have work go. So big isn't being used right now. Big is effectively eval, just sort of hand hacked. Until final step sig, that I believe is plausible. State to state until final step sig. So I think if I did what I had, I think this was right before actually nip. All right, it was right before. Okay, so what did we do before? We said something like start id or start app of id applied to id, and then we just stepped it a bunch of times. But now we have to step it with some signature, but fortunately I don't care what the signature is. Because we don't have any top-level variables. Okay, so that reduced to the identity function when I applied id to id. That actually worked. Let's try something messier, maybe. We built that const function before, but we never actually really did anything with it. The constant version of the identity function is going to take... that looks wrong. Maybe I didn't do enough steps. That is a bug. I don't know what's going on there. The const id should be a lambda bound one. So what did we screw up? Let's go check it on one of the earlier machines to see if we didn't screw those up too. Go back to the earliest one. GHCI CK applied to a simple thing. Let's just let step prime equals step. That way I can just use this line of code. lamyvarx. We have a screw up earlier. I guess our little machine that we started with was already flawed. So somewhere along the way we got the environments wrong. Ha! If I apply the identity to the constant function, does that give me at least the constant function? That properly gives me the constant function. But const id does not give me the right function. So we screwed up last session. All right, let's go fix it. Fine. got a little overconfident that the types worked out. What does that do in the CEK machine that is typed, where we shouldn't be able to have those kind of things? It applied to the constant function. Oh, I need to let step prime equals step, so I can just reuse that line of code. That one works properly. Lamb, just nothing. So this guy is stepping out appropriately. But somewhere we fixed this in the typed version, but it was broken in our original untyped CEK machine. Oh, id of const. Yeah, that's correct. This one was correct. What does this one do? Nope, this one's also nope. Lam var just nothing in an environment. That is weird. That should also have another lamb. So what we did is we built like an environment here, but then didn't come back out enough or something. Like, I think this is an environment for a maybe A. It is, because this environment has a type associated with it. So we got a little bit cocky by, I think, maybe I can show the type of the environment here when we go to show env A. I don't know. What do we have to show typeable? Is there a show for type rep? Shows type rep. That takes a type rep. Typeable. I couldn't crush. What we're doing is I've been streaming on Sundays around noon my time. Now I'm trying to do like 5 p.m. on Wednesdays as well, as much as I can. But yes, it's a fairly regular thing now. This is like the 7th stream that we've done. Yeah, so I'll show the type rep of A or something like that. Show this environment. And I'll just require typeable E or something. That seems plausible to me. Now I'm going to need typeable all over this crap. What else do we have that touches env? Cont, all that stuff looks plausible. Anything else here, take show. And typeable. This should at least show us that we are off on the type that we expected. Import. What do we need? Data typeable. What are we on? We're in the old CEK for typed. What's wrong here? Cannot deduce typeable from the need for closure. State doesn't. Oh, state didn't know typeable. Can't match char. Oh, const id is, yeah, giving me something that may be void. So we didn't like step out at the end when we did the top continuation. I think we forgot to get out of the last lambda or something. We went in for fun. But what's the continuation after fun? Right now that's our old top or something. What do we have here? This is a mess. I did warn at the beginning of the stream that this was going to be a far less structured stream than the last few, right? And not just because this is like coding and drinks with Edward Kmet, but step prime is the thing that we just let. Why is that? I'm going to go fix that show instance because it's horrible. Do show. env at shows prec d. E is going to be show paren. D is greater than 10. Let's do the hard thing. Show string, this thing. Shows prec, that thing. At precedence 11. Not shows prec, show string. No, shows prec. Yeah, that actually. Oh, it's like an Aperol spritz or something like that. It was way too damn hot out here, and especially if I was going to come in from the outside where it's already boiling hot, and then come in under all these lights. So, we ordered like a like an ice chipper thing for making like almost like an industrial strength like Snoopy snow cone machine. But now it's like the kind of thing that if I were to, I could probably feed Snoopy to this thing because it's enormous. Did not expect the thing that I ordered from Amazon to be quite so industrial grade. Anyways, so it's just Aperol and Prosecco and like some grapefruit juice or something. And because I can basically just grind up some ice, it stays a little bit colder under the ice, under the lights. So where was I? I actually started drinking these visiting Bartaj when he was in Italy. He would trot these things out in the afternoon, and learned how to make them from that. Anyways, where was I? Completely lost my train of thought. So we've got... I don't really like the fact that this is building a lamvar just nothing, but we're in an environment that has an extra thing in it. We should come one level out, and I don't understand why we're not. I will be coming to visit Bartaj in Seattle. I'll be there in September for Lambda World. So I will see him in Seattle. They just asked me to finalize my travel arrangements and stuff, so I haven't done all that stuff yet. So how do we fix this state lam var just nothing thing where I've got an extra environment level that I don't want? Do I want to remember that I came in from a lambda? Or is the fact that I'm at a lambda and I got stuck here okay? Well, I think this is actually okay. Gherkin Glass. I think it's how to describe this. We want to go into the lambda. We want to evaluate. We want to not necessarily have to come back out because we've got the argument. We could modify this old style of environment to what do we want to do here? This is the old typed one. We could maybe come up with a way to show these things. We would need some kind of like countable thing for A, and then maybe A should lift countable to countable. And then we could enumerate everything in the environment to show that it's okay to do that lookup. But I kind of, I don't know. There was, I think VibeHab last time was talking about the fact that Matt might had a CEK write-up in Haskell, which was very much in the spirit of what I was writing here. Ref lambda and my applications, yeah, okay, variable expression. Terminal, this stuff is fine. His continuations are pretty much my argument and fun continuations. Let's see if we missed something. His step function and my step function look very similar. Thank you. Common linguistic roots. Look up a variable in an environment. Yes. If it's a closure, yes. We are going to build a new state. His state's just a triple of the current lambda, the modified environment, and the continuation. That's all fine. For applications, okay, this actually lines up almost exactly with my code. CF, CX, we've got the environment. We've got the current continuation. We are going to build an argument continuation. That's exactly in terminology. Slightly different notation. There's my environment. My E is my control, so it's control for X. It's fine. Environment and F. I believe this thing. So I believe these two lines of code that we are the same. My step for lam, as long as I'm at the arg continuation, is going to be to take the argument control and the modified environment from the argument. That's true. And build a fun control from the body of my lambda, yes. And my environment, unmodified, my raw environment from here. And my current continuation. But this guy is this thing right here. So that's correct. That's the continuation that we got from arg. Not the K that is this arg. Okay, so we agree on that. And then the only thing that we have left is this lambda body thing, where if we're looking for a lambda, check. And our current continuation is a fun continuation. He's got B prime as his E. That's my E here. Okay. Check. We've got our modified environment. We've taken E prime. That's gamma, or whatever the fuck prime, his notation there. And and he's doing a substitution for X because he's got environments with names on them. I'm locally nameless. That's close enough. Well, this is very similar code for our current continuation. And K prime is this one that's inside of here. That's what he calls this chi or this X or whatever. Okay, so this is actually the same logic we use. Does he have the same bug that we do? If that would be interesting. Is there source code to this? Can I download it? Come on. No, I can't. Fine. Let's grab the post text and just build mapmite.hs. What did you do, Matt? His terminal is my call it until. I'm going to have to turn on Unicode syntax, I guess. Evaluate is my eval. I clearly read all the same papers. Let's see. Type, fine. DS is clo lam, fine. Da da da. Is inject. Step. It's got a bunch of auxiliary functions. Just to write this line of code. Got to check for his final. That's it. .45 typo for inject. That's fine. Let's turn on Unicode syntax maybe. Nope. 46 typo. He missed a paren, or I missed a paren when I pasted his terminal check. Nope, I missed the paren. That's my fault, not his. Program. He takes a program and calls it a sigma. A program is apparently a EXP. All right, we've got a thing. Looks like it can handle functions. So let's build the equivalent of our id, and this is a program. Will be a lambda with what's its body? Ref. So lambda here is variable colon arrow thing, and then we do refs. All right. Const is a program. And the const program in this vocabulary is lambda. Lambda. I think. All right, and then if we were to do an evaluate of the identity, or inject of the identity, oh, evaluate just takes a program. I don't have to inject in his world. And this gives a function from var to d. I can't show var to d. Just to get moving. can't show expressions either. What are your... I need that in there. I need that on here. I need that on here. I need it on here. I guess I need it on there. So let's see how Matt does it. Helps to not typo a function. So evaluate. What was his notation for app? His expressions had id. So I look at const applied to id. Oh, interesting. He has the exact same bug or what have you that we do. He has lambda y to a reference to x, but x is in his environment. Interesting. I apologize for crunching in the microphone. So I don't want to stick here. I want to actually pop out of my lambdas as long as my environments are not A's. Right? I think that's the different. I don't want to get stuck as long as my environment is non-empty. I want to reconstruct a lambda and then pop my way back out. So let's move out to like CEK int. See if we can just fix it in the latest version of everything that we just built. So we were saying final as long as this was top. But what if we did something like, if you're at a top continuation and the environment isn't empty? Then we're totally done. Otherwise, do something messy to pull something out of the environment. Is it the innermost or the outermost term? I guess we'd pull the innermost term out and throw a lamb on it. What's the viewer? So seek.viewR, the environment of, if it's empty R, then we just say we're stuck. Otherwise, we did not find an empty environment. We found an environment that has stuff in it. We want to glue that freaking environment back together. How are we going to do this? I've got the lambda. I've got the argument. Maybe I'm okay with, I don't know. I don't know if I'm even making sense here. And it is viewer. I'm thinking, and what did we say this is? I want this to give back the I want it applied to the constant function to give back. And I want const id to give back a lambda of 2 arguments. And the fact that it's not is troubling to me. It's like something like, here's it's a lambda that takes another argument, and then we pull the argument out of the environment. So we're at the top. We're going to keep iterating on the current continuation. Fine. We've got a lambda for a body. We're going to iterate here. We're going to do something to this thing. I really want to put the argon somehow. Lam B. I'll do this the wrong way and see what happens. 78, this is that garbage. These are lying around. What happens? We're back in my code. Eval. What was this? Start const applied to id. What do you do? I need an undefined environment or something like that. Lam bound 1. We still didn't. So we have a non-empty context, and we stop. Oh, because is final hasn't been modified. Seek.empty e. Let's seek that null. Derp. And yeah, I know control R is there. It's not in my muscle memory. Eval undefined. Hey. If I want to build an empty environment, I need to do substitution, not abstraction. Trying to avoid doing substitution on terms. I'm not quite following you, Manip. Yeah, so is it in the case that in the end you get lambda y to x, where x equals id? Oh, got it. That's a good question. So what we should do is we should, instead of doing this thing, which is wrong, which kind of works in this one broken case, I think I see what you mean. I've got an environment. If I should run through it and do the substitution into the terms. Okay, so I've got a top thing, which is a lambda, which we know we are done with. So what we want to do is substitute into B. Substitute the environment into B. The environment holds on to values. Values are closures with environments associated with them. So this is a lambda. This is a body to a lambda that needs this stuff substituted as well. Well, keep in mind this version of things is locally nameless, so in some sense it makes the substitution less tricky than it seems. So can we build a little subst function that takes an abstraction of A and an environment of A and gives back a I guess just the unmolested abstraction of A. Substitute. Just call it subst, I guess. So subst for var v is going to look it up in the signature. And so I'm okay with leaving that alone. Because we've got yeah. Substitute for bound k in the environment E is seek.index E. And that gives back a value, but I need to convert a value to an expression somehow. I'm making this up. I don't know if it's going to work. App LR. Environment is app subst L E subst RE subst and these probably should have the other argument order. Environment of A to abstraction. And the environment is really, because the environment is a sequence of values, and values are closures that know their own environment. So I'll be able to kind of, I hopefully just do this value to expression thing in isolation. Hopefully now we've got a substitution. This is why I hate these machines, because they tie my brain in knots. Why I prefer much more strongly typed versions of this stuff. Even this version isn't strongly typed enough. What do we want to do here? Got an environment. I've got a lambda that holds on to its own abstraction. So we've got two levels of abstraction. I need to give back an abstraction. Here, what I want to do is like shift all the variables in this environment by one thing or something like that. Can I build a thing that takes an environment of A and gives me an environment of A? This is a sequence of values, and values are abstractions and environments. Shit. I mean, I'm hoping that they could actually work out, because it seems like it would actually be really clean if I can do the substitution and come back out. I just y to x where x equals id versus lambda y x to x. Yeah, that's true. And yeah, you probably do have to look out for variable capture. Whew. This is a lot messier than I thought it was going to be today. So Manip does have a pretty good point. I find it harder to read the lambda y to x where x is a thing. And I guess the thing that I don't want is that in this version that's got integer things, I don't want those to look like bound variables. I think if I've got a bound variable and I'm under so many lambdas, those should turn back into their terms. There should be some kind of limited substitution that we do here. Because bounds for the wrong counts feels really wrong. And yeah, I would expect that the lambda should be that's that suck end thing that I was trying to do. Well, the problem is our environments aren't this is the problem with switching to the machines, which I'm less familiar with just working with the machines than I am more working directly with substitution and then trying to make the substitution more efficient. That's one of the reasons why I'm trying to do this, because it's an attempt for me to learn. And last time I think we got to a pretty good place, but today I am flailing around like crazy. So to print the environment to see if there looks something that looks like a lamb. So everything in the environment looks like a lamb because everything in the environment is a closure. It's like the body of some lambda with an environment to go with it. That's the only way we ever build anything in our environment. This may be the least productive stream I've ever done. I mean, it's causing us to bounce off of all sorts of wrong-headed abstractions, so how do we fix it? First of all, that should be a strict accumulator. Not that it matters. It just offends me. So abstract looks right. Lamb looks right. Closed looks right. This environment holds onto a sequence of values I could believe. Somewhere along the way, so we started with a thing that did kind of what Manip is talking about. The CEK simple version. And here we started with eval of lambda x var y in the environment, but then I can case that of state CEK EX contains what? What's an environment here? Oh, env is E bang X there. I don't have the ability to show values in this simple version. Driving show. Now I do. Yeah. So X in the environment is the identity. So that is exactly what Manip thinks it is. So I think in the simple machine, the one that Matt Might is using, or more or less, basically that we've determined that they're morally indistinguishable, because they kind of do the exact same thing here. His values are more or less the same. His environments are functions that look up the D, and his data types are his contents of his addresses are only closures that hold on to a lambda environment. So that's actually identical to the naive substitution version that I started with. Huh. So I think it's more forgivable in that setting where it's just using naive substitution. In the attempt to make it smarter by moving to a locally nameless representation, I apparently screwed that up. Right? Because now we reference... Well, I mean, did I screw it up? I guess. Like the distinction between bound and free variables, eventually I'm adding new free variables by doing sucking, and then the environment tells me how many of those things are actually free versus the I can have more bound variables that are bound for real, I guess. And what we're finding in the top situation is we've made a new free variable, which is an identity function, and carried on in a machine that now has more free variables than we started with. And my assumption was that we didn't need to do that, and that looks to be where the impedance mismatch is. So me attempting to call all of the justs and sucks, all of the things that are nothings in the CEK typed code that we have, that looks to be where I had my flawed understanding. Does that make sense? So how to fix that? Or do we need to fix that? I don't know that we need to fix that. But we do need to fix it if we're going to try and move on to this version. So I think there it's okay. We try to move on to this integer machine. These things aren't really bound until you cross some integer threshold. And the current active integer threshold might be part of our state. Huh. Well, that's a damn mess. Any ideas? No, I don't have one there. Hello. I'll take one out. By the way, just got home. Take a Diet Coke. It is going to keep me functioning perhaps a little bit longer. I don't know that the attempt that I was just doing then is all that sound, because I was trying to say we kept the old variables and then just bound fresh integers, but now we're actually what we saw earlier was that our very simple machine that when we came in and then came back out was binding new free variables based on these variable names. Not sure that we're going to be able to finish this modified machine. Okay, so CEK int is just going to become CEK dead end, I guess, right now. Remove. And do we want to try and tackle the Sestov paper, or, I mean, how are people feeling? I think I'm content to let the attempt to make... So there's a paper by Sestov on deriving a lazy abstract machine. I will send the link to the chat. That's not the right link. Let me do a better link. Fine. ResearchGate, you win. I will click this then. So let's try that one. Let's look at this one at least. So this paper is kind of nice in the sense that it kind of starts from an old. Oh, I don't want to deal with your sign up nonsense. Here we go. Deriving a Lazy Abstract Machine by Peter Sestoff. This was the one I think last time or the time before we were talking about how having a CEK machine can be useful for things like supercompilation. And this was the paper that Max Bolingbroke and SVJ used when they were trying to pick a CEK machine to do supercompilation for the Haskell. For Haskell. And like the machine here starts from a semantics by Launchbury from an old paper in '93. And what he's doing is, here's the lazy semantics of quote-unquote normalized lambda expressions. So he, like, these expressions, this x is only a variable, for instance. So you can't apply terms to terms, you can only apply terms to variables. So an expression can be, let me blow this up a little bit larger, it can be a lambda of an expression. It can be an arbitrary expression applied to a variable. It can be a variable, or it can be a let. And then some normalization, kind of ANF style, is done to try and ensure this stuff. And then there's these sort of like the naive simultaneous substitution description here. And this actually, this description at the beginning of the Sestoff paper actually kind of messes with me. Because at this point, I don't believe it. Because up until now, here we've got an expression. An expression for an application is an expression applied to a variable. And here we've got an expression applied to an expression, but we do an expression applied to an expression with substitution, and that's wrong. So I think there's a bug in the semantics in the very beginning of this paper that just kind of got swept under the rug. At least that's my thought from right now. So that's, so basically what he does, so Sestoff starts with this machine from Launchbury, and he builds a heap, kind of like this, what we were talking before about building CESK machines, where the S describes the behavior of the store, and then sort of starts with a very simple machine that Launchbury described, but Launchbury's original machine sort of relied on you doing substitutions into terms, and those substitutions are more expensive than we would like. So he builds up a sequence of machines where he starts replacing bits and pieces of it to get rid of the substitution bits. Yeah, so that's, so E prime slash X means whenever you find an X inside of this term, replace it with this expression, E prime. So Sestoff does I think 3 machines in here that build on the basic Launchbury machine. So, I mean, since we kind of spent so long kind of chasing after that CEK int thing that turned out to blow up in our face, maybe what it would make sense to do is to pick this up in a couple of days, either on Sunday or would folks be interested in perhaps in a stream on Friday at this time? Like doing a 5 p.m. Eastern time stream on Friday? That would give me a couple of days to, figure this stuff out. All right, then let's do that. I'll plan to do a stream on Friday. And during the week, maybe these might wind up being closer to this hour and a half kind of format. And yeah, I understand it's a little bit late for EU, but then if we do it earlier, then it's even more brutal on the Australians, as Puff and Fresh, Tasmanians, can attest. So that was one of the reasons why I was trying to slide something into the afternoon. This is still pretty brutal, I think. Puff and Fresh, is this this is stupid early your time, if I remember right. It's not as bad as when I started streaming at 2 a.m. your time. But yes, I think the ones during the week are going to wind up being a lot less like this. They're going to be more like me flailing around trying to figure stuff out. So I warn you now. I'm perfectly happy to do these. But we're gonna be discovering a lot of stuff together. And I guess if you were looking for that kind of insight into my process, I believe that he probably did. I did not actually see him from that comment. For me, the thing that I'm trying to do is I'm looking to build a thing through Graal and compile it for real. The reason I'm looking at the partial evaluation thing is that one of the things that I'm interested in doing is SPMD on SIMD evaluation, and I know how to do that on the JVM, on JVM 8, modified for Panama through the Intel Vector API. I don't know how to do that on current Graal because the Intel Vector API hasn't been ported forward to it. And so what I was hoping to do was, until the Intel Vector API gets ported forward to JDK 10, or something that's got Graal in it, was to try and steal this trick for a little while. And that would give me a code path that I could actually compile on the JVM, one of the things that I'm interested in playing with today. So this is more or less a thought experiment. It's not, I'm not trying to put this into production yet. So it's definitely an experiment. But I'll definitely read that article from Paul. Compilation versus partial evaluation. Not sure we'll stick to it. It's a bit fragile. So one of the things I've noticed here is one of the reasons why I was looking at the Graal and the JVM CI thing is you get more hooks to say, hey JIT, please JIT this for me. And I think one of the problems that you're going to see with this sort of like compilation via partial evaluation thing is that unless the JIT runs at all, those code paths are dead. How do I keep track of papers? I memorize that they're there, which is a horrible system. Every once in a while, I'll write down a little text file with here's all the papers that I can think of in a given space. But I'm pretty bad at keeping track of those text files, and they tend not to survive me moving to new machines. So. Anyways, I'm interested in experimenting with Graal mainly because it would give me something that ran on the JVM. And the idea of stealing a march and using the last two stages of fluid and mirror projection to get me something that can substitute for a compiler until I can get around to writing a compiler is a big step. Is a big potential win. So I have all this stuff that I want to do with Coda, which is this pet programming language project that I'm going to be working on pretty much full time, actually, now. So I'm getting some funding through the Machine Intelligence Research Institute to work on open source stuff for the most part and kind of push forward functional programming as in the large. So I'll probably be spending a lot more time on Coda and compilation stuff as the content of the stream for the rest of this year. Just as a bit of a low-key kind of announcement. I'll give a bigger announcement about that probably in the next stream or something. So that's, I guess, everything I expect to be able to reasonably get through today. If we're going to try and pick up going through, I'm really excited about it, Tolt. I think it'll be a lot of fun. So that, like I said, it's a very low key announcement for something that's a big change for me. Will some of the Coda work trickle down to Haskell? I don't know. So I'm very deliberately trying to work on Coda as its own thing. There's a lot of things that I'm trying to do there that require big jumps. And so I just don't know how to get them back into Haskell. So I just don't know how to make this project serve so many masters well. So I'm just trying to do it as its own kind of entity, and then later on, we'll see if any of it transitions to be just general Haskell goodness. In the meantime, if I have to do if running on the JVM is a path forward for me on it, then I'll probably be spending a lot more time with Ada, which means that Rahul will continue to get bug reports and things from me. I mean, he's been amazingly responsive so far. So he just recently backported Backpack to run on Ada, which is amazing to me. So I'm going to have to start testing that in Anger pretty soon. All right. Since we've kind of devolved into chatting, and I don't see where this is going to go code-wise today, I'll set up a stream for Friday at 5 p.m. Eastern. I'll put that in the tracker below here. And Miri is exactly the thing that Yudkowsky started. So they basically care about making sure that if you have artificial intelligence, that it is aligned with kind of human goals, or is at least alignable. Whereas if you were to start trying to build it out of like a lot of the things that we know right now, that's not necessarily the case. And so they care a lot about the kind of symbolic computation, just like the sort of almost the functional programming building blocks that I do. And so, I don't know that all of our values are perfectly aligned 100%, but I think if you look at like the dot product of the direction that my stuff is heading in and the dot product of the direction that their stuff is heading in, I think it's at least positive, if that makes sense. And here's where I hold quietly, waiting to see if there's responses in the chat, because there's the 30-second latency. All right. Then what I'll do is I will wrap for today and pick up on Friday. So, thank you, everybody.